Alrighty, so the lesson for today. Today, students will be able to write linear equations in two variables given a table of value, a graph, and a verbal description. We're also looking at linear reasonable fit. That's what we're looking at. So linear function is just a straight line. Linear parent function is y equals x. It goes straight through the center. X-intercept is where it crosses through the x-axis. Slope is rise over run, or the differences of y's over the differences of the x's. Y-intercept is where that line crosses through the y-axis. Positive slope, reading it like a book, it goes up. Negative slope, read it like a book, it goes down. Zero slope, okay? Zero slope is a flat line. This equation right here of this line would be y equals 2. Y equals 2. Okay, undefined slope, straight up and down. Undefined slope, this equation here will be x equals 3 because it crosses through at 3. X equals 3. So zero slope is y equals, undefined slope is x equals. Standard form, ax plus by equals c. Slope intercept form, y equals mx plus b. Point slope form, y minus y1 equals m times x minus x1. Parallel lines have the same exact slope but never ever touch. Perpendicular lines cross at a 90-degree angle, and their slopes are opposite reciprocals. Okay, so your lesson for today, we are looking at linear regression or linear best reasonable fit. Okay, I'm going to do a few examples with you, and then you are on your own. So number one, for the graph of the data points, lay your ruler along the best fit line and draw the line of best fit. Which of the following is the best approximation of the slope of the line? Okay, so you could do that, or, okay, take the points. So point A here is at 1, 2, 3, 4. So negative 4 and 1, 2, 3, 4. Negative 4, negative 4. The next one's at 1, 2, 3, negative 3, down 2, negative 2. This point is at 0, down 1, negative 1. This point's at 1, down 1, negative 1. Okay, this point, it's at 1, 2, 3, 0. This point's at 3, and it goes up 1. This point goes over 4, goes up 1. This last one goes over 5, and up 1, 2, 3. Okay, so we're going to take these points and put them in your calculator. Okay, so go to Stat, Edit. We'll type these in. Remember, all the x's go into L1, all the y's go into L2. So negative 4, negative 3, 0, 1, 3, 3, 4, and 5. Then you're going to type in to L2, negative 4, negative 2, negative 1, negative 1, 0, 1, 1, and 3. Okay, so now we go Stat, over to Calc. This is linear. It says it was linear. So we're going to pick 4 for linear regression, 4. Hit enter. Okay, it says the slope is 0.619. That's your slope. Okay, so which one of these is closest to 0.619? A is. It's at 0.5. Now, remember it's not exact because you're just kind of guessing what the slope of the line might be. Okay, so 0.5 would be 1 over 2. So go up over 2, up over 2. Like that's what they were doing. Okay. All right, next one we're going to look at is number 5. Number 5. Number 5 says the scatter plot needs its line of best fit to be adjusted. If the line shown has a slope of 7 over 6, what should the slope be changed to in order to get the best fitting line? Okay, so again, first point, it's at 0, 1. Next point, at 1, 2. Okay, you can do all that or, okay, it says This is what they have right now. We want to find the best fitting line. So let's do, it's obviously not negative because negative goes down. So that's gone. Okay, but if we did 1 over 1, that means it would go like this. 1 over 1. 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 And 1 over 1. Okay, so does this line look like a good fit? Very possibly, okay? So now let's try 1 over 3. So we go 1 over 3. Does that look like it's going to fit? From here to here, like that? Definitely not. So that's not going to work. What about 10 over 7? Let's try that one. So if we start here, we go up 10, which will be about here, over to 7, which would be about here. Does that look like it'd fit? No. So the line of best fit would be 1. Okay? You're just looking for the line that best fits. All right, number 7. Number 7 says, a student hangs different weights on a vertical spring and records the different distances stretched in the data table shown. Assuming force caused by these weights F varies directly as distance stretched X, what is the best model? So how do you think we're going to do this? Stat, okay? So go to Stat. We want Edit. Go clear everything we have. Clear, Enter. Clear, Enter. Okay, so 0, 7.1, 11.7. Oops, I did 100. Okay, 19.4, 28.6, 34.9. Then we're going over. So we have 0, 2.5, 4.1, 6.8, 10, and 12.2. Okay, now Stat over to Calc. What are we choosing, 5 or 4? 4, because it's linear. So this gives us y equals 0.349, 349x plus 0.011. Which one of these looks like the best choice? Which one? Yes, B. Because this is really close to 0, okay? Which, that's what this is, plus 0. This one is almost 0.35, so you will go with B. Okay, this is line of best fit, okay? Line of best fit. Okay, so now we're going to look over here at 9. The set of data represents the cost to ship packages of varying weights through the United States Postal Service. What equation would best represent the data if the first column is X and Y is the cost in dollars for the weights in that row? Okay, so you're trying to find, again, the line of best fit. So how are you going to do this? Stat. Okay, so I would use this and then use this. Okay, so Y1, Y2. Okay, let's go to number 11. Number 11, Dalia noticed that her tomato plant grew new leaves at a steady rate. After the plant sprouted, she recorded the number of leaves on her plant on various days. See the table. How many leaves should she expect on the 32nd day? So we have 20. We want the 32nd day. Okay, we're going to use Stat. Type in this table. So Stat, Edit, clear what we have. Okay, so we have 8 days, 12 days, 16 days, 20 days. Then we have 31 days, 40 days, 49 days, 58 days. Stat, over to calc. What are we choosing, 4 or 5? Why 4? Because it's linear. Okay, so we get y equals 2.25x plus 13. Okay, they want to know what is it after 32 days. Okay, so go to your calculator. Y equals, type this in, 2.25x, whoops, hit the wrong button, x plus 13. Go to your table. And what number are we looking for in the x? 32. Now here's a little tip. You can do second table set and just type in 32. And it'll take you to that on the table. Okay, so what does that say? 85. D. All right. 13. Daniel is processing a large document on the computer. His scatter plot shows how many pages he produces each hour. Using the information, what is the best prediction of number of pages Daniel can produce in 10 hours? Okay, so we have up until about 8. So they want to know at 10, what's the best prediction? So at 10, is he going to have 2 pages? No. At 10, is he going to possibly have 45 pages? Probably not. What about 55? Possibly. What about 80? Which one is the best prediction? 55. All right, so go to 15. 15 says, according to Newton's second law, net force on an object equals mass times acceleration, or F equals m times a. A student applies several different forces to a glider and records the different acceleration rates in the table below. Assuming force varies directly with acceleration, predict the force needed to cause an acceleration of 3.1 meters per second. So they're giving you this one. They want to know what's going to go here to get you 3.1. Where's 3.1 on here? Where would it be between? 2.5 and 3.9. Okay? So, 3.1 will be between here. So which numbers can we mark off? Any of them? 7.1, right? That's way too big. What about 6.8? Definitely not. Okay. 3.1, would that go right here? No. What about 1.3? Yeah. Okay. Questions there? Okay. Last one we're going to look at is 17. This data shows the growth in U.S. computer sales from 1991 to 1997. It is assumed that sales growth is linear and that this growth will continue the same trend as established by the data. Which of the following best represents the sales in millions expected for year 2000? Now, in dealing with years, here's what you have to do. This started at 0 years. How many years later is this from this? 1. What about this from this? 2. And this would be 3. This would be 4, 5, and 6. Sometimes they'll skip days, okay? So it always has to be this. How many years is it from this? Okay, always. So you're ignoring the days. But we are going to 2000. Okay, how many years later is it going to be from 1991? How many years? No, 2000 from 1991. How many years is that? 9. Okay, so we're looking for 9 to give us our number. So you're going to use stat, type it all in, and then plug in 9 for x, and get your number. Okay? So you're going to finish this today, submit all your answers online, and turn it in.